Welcome, ladies and gentlemen. So what I'd like to do is show you how to find the unit vector. So what I'm doing is we're given 4 vectors and we give some in component form or linear combination. It doesn't really matter. But what we want to do is find the unit vector. And basically what the unit vector is the vector with the exact same direction but has a magnitude of 1. So when we look at like this vector, let's just look at, actually I'll do it over here because I'm going to erase it eventually. So if we look at this vector, 3, 2, so we go 1, 2, 3, 1, 2, down there, you can see there. Okay? Now, again, remember when we were trying to find the magnitude, basically what we did for this was to find the magnitude of v, basically what we did is we had to square, actually let me write the formula here, v1 squared plus v2 squared. So basically what we did is we would square the 3 squared and plus the negative 2 squared. And what we got was a magnitude of 9 plus 4 equals square root of 13. Okay. So the magnitude from my initial point to my terminal point was the square root of 13, which is 3 point something, right? Well, when we want to find the unit vector, basically what we're doing is we're taking the same vector and we're just shrinking it down so that it has a magnitude of 1. Now, why would that be important? Well, for further operations, it would be helpful to have the same vector, but rather than having a magnitude of, the square root of 13, which is the, irrational number, we can just have a magnitude of 1, but it's still going to have the same direction. So it's going to be very helpful for us moving on to know what the unit vector is because it's still the same vector. And then again, what's nice about having that unit vector is, if we want to find it at any magnitude, at 5 or 6 or 7, what we'll do later is we'll learn we just need to multiply the unit vector by a scalar. And we can keep the direction, but get whatever magnitude that we want to. So the first point is when we want to find the unit vector, which we'll call u, we're basically going to take the vector and then divide it by its magnitude. Now, there's a couple different ways that we can do this. And I'll show you kind of, a couple different ways to simplify it. But basically, all we're simply going to do for every single one of these problems is we're first going to want to find the magnitude of our vector. And then to find the unit vector, all we simply do is take our vector. A lot of times we like to write it as in component form. And then we just divide it by its magnitude. Now, you can think of dividing by its magnitude as the same thing as multiplying by a fraction. So you can think of it as like multiplying by a scalar. Therefore, I can distribute that into this. 3 over the square root of 13, comma, negative 2 over the square root of 13. And typically with vectors, it's okay to leave a radical in the denominator. We don't have to rationalize the denominator. However, you could also rationalize the denominator here, which I'm not going to show the work, but I'll do that in the next example. And just so you kind of know, you might also see an answer in this format. But typically in vectors, that's not something that we require. But basically, now that vector, if I was going to sketch that, or get those values and sketch that, you would see that that vector has the same direction as our original vector, but only has a magnitude of 1. All right, so for our next example, again, first thing we want to do is find the magnitude. So that's going to be 1 squared plus negative 1 squared. So in finding the magnitude here, I have 1 plus 1 equals 2. Okay. So therefore, I have 2. Now I basically just take my vector, and I'm going to take 1 comma negative 1, and then divide it by the square root of 2. And again, you can just rewrite this typically the way that I accept the answer is just like that. However, if you were going to rationalize the denominator, remember what we do is we multiply by the square root of 2 on the top and bottom. And therefore, another simplified way to write the unit vector. Because remember, square root of 2 times square root of 2 is the square root of 4, which is just 2. So that's just another way that we can write for our unit vector. Now, for these last two examples, we have it in as a linear combination. But again, it doesn't really matter. You can write them in, first thing I do is just write them in component form. But you don't really need to. You understand, hopefully you understand, that when it's written in a linear combination, you can quickly, easily write it in component form. So therefore, if I want to find the magnitude of my vector v, all I simply need to do is basically take the square root of my first term squared plus my second term squared. So that's going to be 9 plus 16. which equals the square root of 25, which equals 5. Now, I basically just take that vector and divide it by its magnitude. So my unit vector u is going to be 3, 4 divided by 5, which again, you can just divide by 5 into both of those, or think of it as multiplying by 1/5. However, my unit vector now is going to be 3/5, 4/5. All right, now in the last example, I'm actually going to use a graphic representation to understand the unit vector. So we have 6i. Remember, I is along the x-axis. So we have, if you remember, oops, yeah, it's going positive. So if you remember, here was my unit vector I, and that was j. Well, if I have 6i, that means my vector is 1, 2, 3, 4, 5, 6. Right? And you can see that this vector from the initial point to the terminal point has a magnitude of 6. Well, we just want to find the vector that has the same direction but a magnitude of 1. So rather than going through all the math, what we can see is, well, if I want to have the same direction but I only want it to have a magnitude of 1, therefore the unit vector is just going to be I, because it's just going to be that one vector going out to the right 1 unit. So without doing all the math, my understanding of unit vectors, I can quickly understand that u is just going to equal I. So there you go, ladies and gentlemen. That is how you find the unit vector from a vector. Thanks.